So hello everyone to another lecture. Here in this lecture, we'll discuss about why should we learn the linear system. Like in the previous lecture, I mentioned the LTI system, linear time invariant system, right? So why why to learn the linear systems? In the other words, you can ask, what is the beauty of linear system that we learn? Because most of the practical scenario you will find non-linear systems. But why we are only learning about the linear system? First of all, linear system is easy to analyze and understand. So if you understand this, then when you dive into the non-linear part, then it will be little less complicated because non-linear is very complicated. Non-linear systems. If time permits, I will start the lecture series for that as well. And another thing is it's less complicated. And the beautiful property that a linear system has, it's like I had mentioned, one is homogeneous, homogeneous, and another is superposition. So we know whichever system satisfies these two properties, we can say it's linear. Pratik, if you may ask, Pratik, you are just saying these are beautiful properties and all, but how? We can't relate it, right? So wait for a few minutes. You will understand the beauty of these two properties. So how to exploit these two properties? I don't know what's happening to my writing today. Okay, how to exploit these two properties? Before making you understand this part, I will take you to a little side. And do you remember the Taylor series? You might have heard the Taylor series. No, I'm not talking about any singer or something. Just the Taylor series. What Taylor series says any function f of x can be written as the sum of this f of dash of a. Like Taylor series at some point, about some point a, a is the point. So x minus a whole divided by 2 factorial plus f double dash of a by 2 factorial into x minus a whole square plus f triple derivative by 3 factorial x minus a whole cube plus some higher order terms. We call it higher order terms or HOT. Okay. So this property, what we understand is any function f of x can be decomposed decomposed and rewritten as a combination of a constant value f of a constant value. You can see this, everything is a constant. So this constant value into first order with respect to x, and this is another constant, it is second order, and this is third order, and on the higher order, which I am neglecting right now. So what happens is I can say my f of x is a combination of some constant c1 plus c2 into x plus c3 into x square plus c4 into x cube, like till infinite. These are the HOT. So what are the values of C1, C2, C3? We can calculate from the expression. Okay. So this is the ultimately I am getting the expression. So in controls, and coming back to the control system paradigm, you might have, like from the lecture series or from any book you are acquainted, you might have heard the input systems what we take in general, like which one is step input, second is ramp input, third is parabolic input, and another is there that is called impulse input. So mostly whichever standard book you follow or standard lecture series you follow or anything, they will be mostly talking about these inputs only. So given a system, like given if this is a system, let's call it G of S. So I will explain what S is in later videos maybe. Let's just know that S denotes S denotes the Laplace domain transformation. So I will explain like why Laplace is important and all. So okay, coming back to our question, here we know we give some u, control input u, and we get some r. So mostly you will find this u is either step, ramp, or parabolic, or impulse response. So you may wonder if my system, I'm working with a system, there is a possibility any input can come. Why it will be only a step input or ramp input or parabolic input or impulse input or anything? It can be my input can be like in this form as well, like something, sorry, something like something like this, and suddenly jumping like this as well, right? So why I'm not considering this kind of input, I'm only considering step input, which is like this with respect to time, like it's a constant, and in ramp input like this, in parabolic input it's like this. So and the impulse response is just this one, like at 0. So why I'm only considering these 3 or 4 inputs? Because as we know from the Taylor series approximation, any input what I am getting, I can decompose it in its 0 order, first order, and second order. So any input u I am getting, u of t, I can decompose it in its some first 0 order dynamics, which is a0. So first order into some x plus second order some x square plus the HOT. Okay, so now comes the beauty of the linear system, the homogeneity and superposition. So just look at it. So if my system, like the GFS, which I am giving the U, okay, I require what is my R is, like response. So let's as like decompose the input itself into different parts. One is GFS G. Okay, so the same GFS here and here. Okay. So now what I will do, I will give the input of some x to the power 0. Here I'll give some x to the power 1. Here I'll give the input x to the power 2. Okay. Sorry, I'll just, it should be t. So it's better. Similarly here, this thing should be t. My mistake. Pardon me. T to the power 0, t to the power 1, t to the power 2. And if we are getting some output R1, R2, and R3, so if I multiply some constant A0, due to the linearity property, the output will be A0, A1 into like this, A2, A2. Okay. This property, this is because of the homogeneity property of a linear system. So now, if I assume my G as a linear system, then what I can do, I can combine these three results and simply put G of S is equal to the sum of A0 D0 plus A1 D1 plus A2 D2 plus the higher order term which I am neglecting right now. Output will be A1 A0 sorry A0 R1 plus A1 R2 plus A2 R3. This will be exactly the same as our R because of the linear property, the superposition property. Super property. This is the concept, like you like very less book explain, and this is a property you should learn, you should know, because why we're only learning about the step input response or some ramp input response or some parabolic input response? Why? So this is the reason why we only consider currently the step, ramp, and parabolic input responses, so that any signal you comes as an input, we can decompose it into this form, and if we know the responses of the parabolic step, parabolic, and ramp input, we can get overally, approximately, exactly the actual response to the control input. So this is the beauty of the linear system, what I wanted to explain in today's class. In the next class, we'll be discovering some property about like why like the closed loop and open loop systems. So till then, thank you.